Alright, this time I'll talk about the problem Raucous Rockers. So what we want to do in this problem is basically pick a few songs that will add up into that will have the maximum number of songs, but also fitting a few number of discs. But this may seem like a knapsack problem, aka like a dynamic programming problem, but the constraint here is really small. It's only the maximum is only 20. So you can actually solve this by testing out all the combinations, and that the maximum combination is only 2 to the power of 20, which is only a bit more than 1 million, so we will be able to test that out pretty quickly. And so here we'll just use this bit, and we'll convert this to bit set, and then using the bit set we'll be able to see which ones we chose and which ones we didn't choose. So this way you don't actually have to test out each of those by writing a bunch of recursion or loop. We can actually just do this, and because the bit will increase one by one, so every time it will increase by one, and then it will change a few positions, and then we will have a new way of choosing the numbers. And so I set the maximum here to 2 to the power of n. This using the left shift bitwise operator. This is the same thing as 1 left shift by n is the same thing as 2 to the power of n. And so here we want to loop all the way to L minus 1. We don't want to loop to 2 to the power of n because that will give us an extra bit. And so here we'll convert this into a bit set. So we'll be able to compare each of the bits inside this current combination. And since a bit set requires a constant length, we will just set this to 20 because this is the maximum length that we can have. And we convert this current number I into a bit set, and this will give us the current combination that we have. And so first of all, here we will check the amount of set bits inside this current bit set. If it's lower than if it's lower than the answer that we already found, then we don't really need to search this again because no matter what, it will just be lower than this answer, so we can continue. And here, if it's not smaller than the answer, we might be able to get a greater amount of discs. A greater amount of songs. So we will test this out using this simple loop. So this will keep track of the sum in each disk because we have a maximum length of time that we can have on each disk. And so at first I'll just set everything to 0 here for the sum, and this index will keep track of which disk we're at, and this count will keep track of how many songs we already added. So we'll loop through all of the songs that we have, and we check if the song is chosen in our current combination, which is written here. This can be accessed like an array. Each bit can be accessed as an array, sort of like an array. So then you can get each of the bits. If it's 1, then that means we have chosen this current song, and if it's 0, then that means we don't want to choose this song. So if it's 1, then we will first check if this current length of the song plus the amount of time that we already have inside this current disk at this current index. So we check this, we add them together and see if they're greater than the t. And t is the time allowed for each of the disk. So if it's greater than the time allowed, then we'll just increase our index by 1, meaning that now we will use the next disk because this disk is already too full to contain this song. And here we have to write another statement to break if this is not a possible case. So it will not be possible if the current song length is greater than the required maximum length. So no matter what you do, you cannot put this song inside any disk. But so that means there's no way we can choose this. So here CJ definitely cannot be true. Then we'll just break this. Another case is when index reaches the end. When it reaches the end, this means that we've actually run out of space for all the disk, and so we'll also break that. And otherwise, we will just add this current length of the song into our disk at index. And we'll also increase a count by 1 because now we've added a new song into this whole disk collection. And finally here, after we finish this whole loop to loop through each of the songs, we will check how many songs we've added. If it actually is the amount of set bits inside our current bit set, this means that all the songs that need to be chosen has been chosen. So we will just set our answer to this current count, because we've already made sure that this current count isn't less than answer. So it will at least be as little as the answer. And so this will just keep on going until we've reached everything. So after we search everything, we'll just print out the answer.